Okay, let's get started. So today we're going to talking about projectile motion, and this is the last part of motion. Okay. So what is projectile motion? So before we do that, we need to remember we had two sets of equations. One set of equation is distance equal to vt. Can anyone tell me what is the criteria when I use this equation, d equals vt? Yeah, constant velocity is when the speed don't change, right? Well, unfortunately, a lot of time the speed do change. If speed do change, we have acceleration. So we don't talk about acceleration, a lot of changing acceleration, we only talk about a constant acceleration. So if you have constant acceleration, what kind of equation do we use? Kinematic equation, yes. So it's a kinematic equation. So we got this set of equation, and this equation can only be used for constant speed, right? Okay, so bear that in mind because we're going to use it today. Okay, and now let's have a look. What is a projectile? A projectile is any motion that moves through air without its own source of power. So only under the influence of gravity, and we need to ignore the air resistance. Okay, so what does that mean? So let's have a look of this rubber in my hand. So when I throw the rubber, I'm giving it a force, making it go forward, right? But when this rubber is traveling in air, is there any force acting on the rubber when it's traveling in air?
Yes.
There's no force?
Gravity.
Yeah, there is gravity, right? But there's no other force pushing it forward. As soon as the rubber leaves my hand, and there's no push force anymore, right? I don't have the superpower to move things like across air without touching it, right? So when it's already in air, it just keeps moving. So this is called a projectile because when it's only gravity. So projectile has this shape which we call a parabola in math, right? Okay, so a full projectile is when I throw this thing, it falls down. So it goes like this, from here going up and then come back to this position. That's a full projectile, okay? So today we only talk about half projectile, which is when it goes from top, goes down like that. Okay, when it goes top, I don't give it any vertical speed. I don't throw it downwards at all. I'm purely just throwing it sideways. And when I throw it sideways, and then it just falls down like that, like how we see it over here. Does that make sense? Okay, sweet. So now, let's have a look what happens to the velocity and how do we analyze this situation, okay? So if we look at this object, it was originally traveling with the speed going this way. Let me give it a number. I'll say this is the horizontal speed. I throw it really, really fast. I throw it at 10 meters per second. Okay? Yeah, you don't need to write it down. You can write down later. It will be all left over here. It's on the video as well. Okay? Let's just pay attention and listen. Okay, so the speed is going to constantly changing. So at the moment it's going in that direction, and then it starts accelerating, but it will start to go in that direction, right? And then it's going to start to go in that direction, and then it's going to start to go in that direction, become bigger. You can see this one, not only the speed is changing, but the size of the speed is changing as well, right? And the direction is changing as well. So we can't use d equals vt because that one is constant speed, and we can't use this constant acceleration as well because the direction is changing as well, right? So now we will need to use a new method, okay? So what is that new method? So the new method is this. We have to look at this thing in two directions because we can analyze it in two directions. So at the moment, the speed horizontally is 10 meters, right? So over here, I've written down here, when we analyze projectile motion, we have to analyze it in two directions, horizontal and vertical. In the horizontal direction, there is no force acting. If there's no force acting, according to Newton's first law, the horizontal velocity will stay constant. Does that make sense? Okay, so when the ball comes reaching, say, this position, this is 1 second later, and how big would this horizontal speed be? Yeah, this will still be 10 meters per second, right? Say another second, I take a picture, okay? The ball has landed over here. See, when I draw it, I draw the horizontal distance the same. Okay, I'll make this a little bit bigger. The horizontal speed will still be 10 meters per second, right? And when I goes even more, it's gonna land over here. How big will the horizontal speed be? Yeah, still 10 meters per second, just because horizontal, there's no force pushing or slow it down, okay, because we're ignoring friction. Okay, and then the next one, well, let's look at vertical. A vertical at the beginning, I did not push it downwards at all. So the vertical equal to 0 at the beginning, right? But because of gravity, it's going to start to accelerate in the gravity direction, right? Okay, so how big will the vertical be over here after 1 second? 9.8, right? Because gravity acceleration is 9.8. So every 1 second is going to become 1.8. Another second is going to become another 1.8. So 9.8, let me give it just easier for calculation. Let me say it's, I'll just write 9.8 meters per second after 1 second, right? Okay, and after another second, what does the speed become? It will become 9.8 times 2, right? So let me just say it's 20 to make it easier, okay? You need to use 9.8 when you calculate. So for our easy calculation, now it's going to become 20 meters per second. And when it comes over here, how fast will this speed be?
30.
Yeah, now it's going to become 30 meters per second. It's just going to keep increasing the vertical direction. Okay, so if I ask you, well, what is the total speed over here? Over here, the total speed is just at 10, right? Because vertical, there's no speed. What about the total speed of this one? If I want you to calculate the total speed, how would you calculate the total speed?
Pythagoras?
Yeah, so I need to use Pythagoras. So I'm going to draw. That is going to be my total speed at this position, because it's including these two speeds together, right? Using the vector addition we've learned before. Okay, and then what is the speed over here? I join these two together. Going to start go this way. If I want to know the speed over here, I can join the here together this way. See, even though this red one is actually the speed of this object when it's falling down, but we can't analyze it because the size changes and the direction changes. That is the reason why we're going to use horizontal and vertical to analyze it. Okay, all right, so now let's have a look over here. This two sentence, I put a star over here because you can either have calculation questions like this, you use the equation to calculate, or you can have explaining question. Explaining question, you just purely using these two sentences. Remember these two sentences, bam, chuck it in the question, then you're gonna get a good mark, okay? So in the horizontal direction, you have to say there's no force acting, so the horizontal velocity stays constant, okay? And in vertical direction, gravity is the only force acting on the object, and there's gonna be a constant acceleration of 9.8, okay? And then we use kinematic equations. Okay, so now let's using these concepts over here and to see how do we actually solve a problem, okay? So we're gonna move to that side. Move my camera. Okay, so this question I'm gonna work with you guys together. Oh, that's all, you're all good. Okay. Oh, this is a bit hot. Just wait me a second. No, you're all good. Okay, see? So let's have a look at this question. It says, when an airplane is traveling at an altitude of 500 meters and is moving at a horizontal speed of 160 meters per second. Okay, say this pen is going to be my airplane. This airplane is flying, flying, flying. A small package is dropped from it. So when you're traveling horizontal, and then boom, a small package drops. So when you drop the package will be traveling forward as well, right? Okay, say here. Say this is the airplane, and it's going in this direction at 60 meters per second, and it drops a little package, and the package is going to go then on the ground like this, you can imagine, right? We're ignoring air resistance, okay. Say, you want to drop this packet at the exactly right amount of time. So I draw, there is a height, which is 500 meters. Because it got this projectile motion over here, say this, if this package is some really, really good resource and we want to, say, medical resources to help with coronavirus, right? And you live right over here, okay? And your friends want to drop this package. You don't want it to drop it right on top of you, because if it drop it right on top of you, it's gonna end up over here, right? Let's say, oh, if you're at a war. If you're at war, you want to drop a bomb and bomb the enemy, right? But you are standing, the enemy is over here, and if you drop the bomb right on top of the enemy, where is it gonna end? It's gonna end up hitting you over here. So that's not very good. So we have to be able to calculate, well, where do we supposed to drop it, considering how this is gonna be a projectile motion, right? Okay, let's have a look over here. Calculate the time it took for the package to land on the ground. The time for the package to land on the ground. So first question is, we know this is projectile motion, and we need to analyze the horizontal and vertical. So which direction are we supposed to analyze for this one? The time taken for it to land on the ground. Which, does the horizontal make it land on the ground or the vertical make it land on the ground? The vertical. Vertical make it, so we have to analyze the vertical direction. Does this make sense? Okay, so I'll write here, I say in the vertical direction, okay, let's say what are the information we know in the vertical direction. First, we have a 500 meter, and that is going to be my distance. Right? Okay, and there are two hidden information. Can you guys have a thing? What are the two hidden information over here? Yeah.
Initial velocity is 0 meters per second, and
yeah.
acceleration is 9.8.
Okay, so over here, we've talked about in the vertical direction, the gravity is only 4, so there's a constant acceleration of 9.8. That is the gravity acceleration, okay? And also horizontal, I did not throw it downwards. I just let it drop downwards. So there is initial speed started from 0 and then drops downwards, okay? And what happened to horizontal doesn't matter, because horizontal is not going to bring it down. Only the vertical matters. Okay, so now, then the question asks us to calculate time. What we do is, we go have a look, okay, the equation we need to use is the kinematic equation. So we find out which one we can use to solve the problem. So I need to have all these 4 things in there. So what I don't have is a final speed. So anything with final speed, then I can't use that equation, okay? So if I go here, final speed, I can't use that. Final speed, I can't use that. Final speed, I can't use that. So this is the only equation I can use, okay? All right, so then I go, well, D is going to equal to VIT plus half AT squared. Okay, and I can put the number in. Well, there's a 500 equal to 0 times T at half times 9.8 T squared. So 500 equal to 4.9 T squared. So T squared equals to 500 divided by 4.9, and then T equal to square root this thing. Okay, can anyone quickly put this in the calculator and tell me how big is the time? Okay, does anyone have a calculator? Should be around 10, I think. 10.1? 10.1? Oh yeah, great. Okay, so I know now it takes 10.1 seconds for it to land on the ground. Okay, all right, so now the next one. How far is the package moving horizontally? Well, this one is easy because it's already telling us horizontally. So we actually just need to use horizontal equation, right? Okay, so I'll say in the horizontal direction. Then what is the equation we use for horizontal direction? D equals VT, yeah, only one equation. Horizontal difference is easy, but this V, I'm going to add a little horizontal. This D, I'm going to add a little horizontal to show us this is horizontal, so I don't get myself confused because they are too distant here, right? Okay, and also T, I mean, T doesn't matter because time is time. It doesn't matter where you travel, the time is a constant, right? The time it takes for it to land on the ground is also the time it takes for it to land over here. That's why time does not matter, it's the same time, right? Okay, and then I put it in here. Well, what is my horizontal speed? That is, it's given to me at the beginning, 160 times 10.1 second. And then I put that into the calculator. So I'll get roughly 1,600 meters. So I'm going to travel 1,600 meters over here. Okay, that means when you drop the bomb, you want to make sure that when you have 600 meters away, you need to click the button and drop the bomb so it will land on the enemy's ground. Okay, all right. So last one. What is the speed of the packet when it hits the ground? Okay, all right. Don't worry about writing it down yet. I'll leave it here. You can write it down. Okay, the speed of the packet when it lands on the ground, we have to look, well, what is the speed made of? There are two speeds. One speed is going to go in this direction. That is the horizontal speed. Just like this situation we have here. If we want to know the red, the actual speed, we have to know the blue and the green. If we know both of them, then we can know the final speed, right? Okay, so that is my blue one, which is 160 meters per second, not changing. If I can find the green one, which is the vertical speed, if I can find that one, and then I'll be able to combine them together using what we've learned from the previous lessons, right? Okay, so now, all of a sudden, I need to know this speed. So what kind of speed is this one? Yeah, but it's not gravitational speed. It's a vertical final speed. Because originally you started from 0 over here, and then when it's landing on the ground, there is a final speed. Does that make sense? Okay, so now again, we need to go back to the vertical direction. This is vertical direction. We want to find the final speed, okay? So in the vertical direction, we want to know what does V final equal to. Okay, we're coming back to the vertical direction. Well, what equation I can use to find the final speed? There's final speed there, I can use that one. Final speed, I can use this one, or I can use this one. So this one is actually going to be the easiest one, okay? So I'm just going to use that one, okay? So the V final going to equal to VI plus AT. Okay, what is VI? VI was 0. There was no vertical speed at the beginning. And then add acceleration, 9.8. And then time, we calculate time here, 10.1. Yeah, so about 99 meters per second. Okay, so now I know the vertical speed at the end will become 99 meters per second. Okay, so now I need to combine these two speeds together to become my final speed at the end, right? So what is the final speed? I do this. That is my final speed V. Okay, what does V equal to? Now I can just use my trigonometry or Pythagoras to figure it out. So this V is a diagonal one, 90 degree here, 90 degree here. So that's 160, 160, 99 here. Oh, I draw this 99 too big. It should be a bit smaller. I'll just draw it to the right scale because this will be smaller than that one, right? Okay, yeah. So now I can draw this diagonal one, call it V. Okay. So then I can put in calculation. Okay, V is going to equal to square root 160 squared plus 99 squared. And then can anyone put this in the calculator for me? What speed would you get?
was literally just.
188.2.
188.2. Okay, so let's just say 188 meter per second. So that is my speed when the bomb lands on the ground, well, or the package, right? Okay, so now, sometimes they might even ask you a little bit more difficult. They might also add another question, say what is the angle the package is going to hit the ground, okay? If they ask you the angle hit the ground, normally they will be asking you this angle, because this is the angle towards the horizontal direction. So if something going sideways, we always say, oh, what is the angle compared to the horizontal? So then you can use trigonometry to calculate this angle theta, okay? And I mean, they could ask you a lot of different changes, so you just, according to the situation, you go analyze it, okay? All right, so this is going to be worth a merit, and this worth a achieve, and this worth a merit as well, okay? But what is the excellent question? What an excellent question is this. They're going to take away the first question here. And then they ask you straight away how far the package will move horizontally. Then it becomes excellent. Okay? So, how do you do that? What you need to think of is, well, how far package move horizontally? I know I will be using this equation because this is the only equation we have for horizontal direction, right? And I know the speed, but I do not know the time. And then you need to think about, well, horizontally I don't know time. I have to go to vertical direction to calculate time, right? So you can add yourself a question, well, what is the time taken in the vertical direction for the packet to drop to the ground? And once you do that, and then you do this first, you get a merit, and then you come to the last step, then you can get an excellence. Does it make sense? Yeah. And then this is all calculating question. Basically, it's all just this. But there is some variation. The question just changes. Sometimes they give you this number, sometimes they give you this number, sometimes they give you this number. They just give you different numbers. But the equation and process are exactly the same. Okay? And then the expanding question will just be using this. Does it make sense? Okay, sweet. And that's it. That's all the explanation I need to do for this topic. And in our book, there are a few questions that we can practice. Okay? I'll stop.